sharing the screen. And today, well, that's not the right one. This is. Today we are going to start looking at Z-scores. Before we start looking at Z-scores, I want to look at another example making use of that 68, 95, 99.7 rule. And I'd also like to start by asking, does anybody have any questions on any homework problems? Anybody want to look at anything from the homework? The total silence that I'm getting, I'm going to assume that that's a no unless somebody's looking for a homework question. If not, let's look at a quick review of that 68, 95, 99.7 rule. And did any of you ever take the SAT exam, the kind of college entrance exam?
Like 25 years ago.
Okay. The SAT exam, it's scaled every year so that it's mean for any section. So let's say for the math section is 500 and the standard deviation is 100. So it's set that way. It's a normal population. Let's use the 68, 95, 99.7 rule to find ... And again, I think I told you folks on, oh, crap, stop. I'm going to backtrack for a minute. I'm thinking that I told you folks on Friday, and I forgot to mention the 3 homeworks are all due a week from today. We should be winding up our study of statistics then, because those topics kind of all meld together. I have them all due on the same day. Don't leave them go till Sunday night. But also, everybody's aware that on Wednesday we do not have class. The campus is closed, right? It's Veterans Day. So I forgot to mention that at the beginning. So now back on Friday, I think we had said whenever we saw that phraseology 68, 95, 99.7 rule, the first thing we did was we drew a bell curve. And in that bell curve, oh, I made it too high. Oh, well, we'll make it work. We said we'd mark the middle with the mean. So what number should I put in the middle here?
500.
500, yeah.
And then we said we counted by the standard deviation. And so here's the standard deviation is 100. I'm going to count by 100, 600, 700, 800, going larger to the left, and 400, 300, 200, going smaller to the right. And then we said between them we'll connect. And this middle one, I had been writing it up above, but I apologize, I didn't leave enough room. Would be the middle 68%. And then when we connect the ones that are 2 away, we said that that would be 95%. And then when we connect the ones that are 3 away, we would get that last grouping of 99.7%. Diagram showing when I ask the questions, I'm going to shrink it a little bit. Hopefully that's not too small for anybody to see. What if I want to know what percent of people score, let's say, between 400 and 600?
68%.
And how'd you get that?
Because it's in the 68%.
The 400 and the 600 are perfect. The boundaries at the 68%. What if I ask what percent of people score, let's say, between 300 and 500?
It would be half of the 68 and half of the 95.
Well, I like the idea that you recognize that it's half. That's great. But let's look at the 300 to the 500. From 300 to 500, isn't that just half of that box for 95? We're going from the end of 95 to the middle. So we're just half of the 95%, which would give us 47.5%. And I have to apologize. I saw there was a chat and I didn't get to look in it and see. Oh no, Zorianne, you're leaving back to the land of cold, although we've had good weather while you were gone. Glad you're here. Then let's look at what percent of people are between, let's say, 600 and 700. Yeah, 600 and 700 are boundaries on different boxes.
Okay.
That's what we're going to subtract. 95 minus 68. And because we're only looking at one of the two possible sides, we're going to divide it by 2.
Okay.
And so that's going to be, what is that? 27 divided by 2, which will be 13.5. And I want to fit one more question in. What if I ask what percent score, let's say, above 700? And so above 700 would be outside the box. So does everyone remember, outside the box, either above or below, we're going to subtract from 100, and that's the boundary for 95. And again, because we only want one side, we'll divide it by 2 and get 2.5%. Has anybody started looking at the homeworks that deal with this? You're going to find that they have all sorts of different situations. But every time it's going to work the same way. You're going to, as soon as you hear that 68, 95, 99.7 roll, you're going to look at your bell curve. The percentages always stay the same. The only thing that changes is the mean and standard deviation, or the numbers that are on that horizontal. If that's all right, I've got a problem. What if I wanted to know not the number of people who scored above 700, but above 750? That's not one of my boundaries. And so in order to do things like look at things beyond boundaries and compare also different populations, we use something that's called a Z-score. is a z-score is a measure of how many standard deviations you are away from the mean. So let's look at S, where the mean is 500 and the standard deviation is 100. And I have to apologize. I wrote that. I'm going to move that down just a little bit. I forgot to give you the formula for the z-score. The z-score is equal to the data value minus the mean divided by the standard deviation. And again, if you're doing this on a calculator, remember that if I'm doing that in one fell swoop, you do parentheses around that numerator. But going back to that SAT, where the mean is 500, and the standard deviation is 100, let's find the z-score for each of the following. So let's say we want to find the z-score for a score of 750. A lot of times when we look at the z-score formula, the z-score is the data value minus the mean over the standard deviation. To say that I'm looking for the z-score for a grade of 750, sometimes you see that as z with a subscript 750. And that subscript tells me the value that I'm looking for the z-score for. And so my data value is 750, my mean is 500, and my standard deviation is 100. So let's see, subtracting, that gives us 250 over 100, or 2.5. What if I want a z-score for a score of 475?
Wouldn't the top be in the negative then? Because you're subtracting 500 from it.
Adam, you are amazing. That was exactly why I picked that number. Because what
Thank
we're
you.
doing now is we're going to discuss what it means if your z-score is positive and what if it means if your z-score is negative. So you are spot on. When I subtract 475 minus 500, then I have to divide it by 100. That does give me a negative 25 in the numerator. And so that gives me negative 0.25. And from those two examples, is everybody all right if we make use of Adam's observation to say that if the value is above the mean, the z-score is positive. And if the value is below the mean, the z-score is negative. And we're going to find that the z-score has several uses. And in addition to figuring if you're above or below the mean, the z-score can be used to compare different members of different populations. And what do I mean by that? I want to go back to an example that we had looked at on Friday. We had said for American men's heights, the mean was 70 inches and the standard deviation was 4 inches. Well, we never mentioned, I don't think, that for American women,
Are you able to find the standard deviation on the calculator, like the TI Inspire?
I don't know how to do it on a TI Inspire. I do know that most scientific calculators, you can just put your data values in and press a button with the standard deviation. However, we're not going to be working with large populations. So when I ask you to find a standard deviation, I'm not just looking for an answer. I do want to see your work. I do
Okay.
want to see what you're out. So, but if I'm sure if you wanted to use a calculator,
Just like to check my work.
yeah, if you wanted to use a calculator to check, because I'm not that familiar with TI Inspire, I would get your manual out. But also,
Okay.
if you're using the calculator to find a standard deviation, there are two different standard deviations. There's a population standard deviation and there's a sample standard deviation. In this class, we're only using the formula for a sample standard deviation. I think usually one of the criteria for the difference between population and sample is the size of the sample. But again, we're only going to be using the sample standard deviation formula. But
Okay.
for women's height, the mean is 65 inches and the standard deviation is 3.5 inches. And so I want to know which is more unusual. A 5-foot tall man or a 6-foot tall woman. Well, 5 foot is short for a guy, 6 foot is tall for a woman. But I can't really just compare them as is because they're from different populations. Has anybody ever heard like the old fashioned expression, it's like comparing apples and oranges? You can't really because they're different. And so to make the comparison, we're going to compare them each against their population. We're going to compare the woman against the woman's averages. We're going to compare the man against the man's averages. So to compare them, the way we're going to do that is we're going to use z-scores. And we're going to say, who's further from the middle for their population, given their population's mean and their population standard deviation. Again, the z-score is the data value minus the mean over the standard deviation. And so for the man, we're going to find a z-score, and for the woman, we're going to find the z-score. The man, again, we're using that the mean is 70, the standard deviation is 4. And what we have to remember is that 5 feet, why can't I write the abbreviation for feet today? 5 feet is 6 inches. And so the z-score for that 60 inches would be the 60 minus the 70 divided by 4, which would be negative 3 over 4 or negative 2.5. And so we say that the guy is 2.5 standard deviations below the mean. And now we're going to have to do that same type of work for the woman. But for the woman, the mean is 65. The standard deviation is 3.5. And 60 is 72 inches. So for her, the z-score for 72 would be 72 minus 65 divided by 3.5. What is that? That's 7 divided by 3.5, which would be 2. And so she's 2 standard deviations positive above the mean. Arithmetic involved, they're okay with everybody. So he's 2.5 away, she's 2 away. You notice that he's further from the mean.
Yeah.
It's more standard deviations away. So it's more unusual. And so that's one use of z-scores, is to compare different populations. For example, I think on Friday we looked at using the 68, 95, 99.7 rule to find out about IQs. I think the last example that we used involved the IQ scores. However, there are different tests, and the different tests have different means and standard deviations. So to be able to compare people who took different tests. In the same way, I guess another comparable example would be some people take the SAT exam before they go to college. Some people take the ACT exam before they go to college. They both test the same thing, but they have very different grades with very different means and very different standard deviations. You know, we could use the z-score to compare those two. Now, another thing that we have to do with z-scores is we have to be able to work backwards. And by working backwards, I mean that if you know the z-score and the mean and the standard deviation, you should be able to find the data value. So let's say if a man has a z-score of 1.3, how tall is he? And so here, the z-score is 1.3. We're recycling that the mean is 70 and the standard deviation is 4. The author of the textbook treats this as a separate formula. At some point in time, though, I kind of reached the formula overload. And so I'm going to go back to our original formula that the z-score is equal to the data value minus the mean over the standard deviation. I'm going to substitute what we know. And solve. So what does that mean? The z-score is 1.3. The data value we don't know. The mean is 70, and the standard deviation is 3. Now, I know a lot of people, when they look at an equation like this, because there's a fraction on one side and there isn't one on the other, they look at it and say, I can't do that. Sure you can. Because what I'm going to do is I'm going to think of this number on the left as being a fraction over 1. And the way it's written, does everybody see that I'm going to just cross multiply and get 4 times 1.3 is equal to z minus, I'm sorry, the data value x sub n minus 70. So I think that gives me 5.2 the data value minus 70. And so adding 70, I get 75.2 is equal to my data value.
Can you go up a little bit?
Is that better? I can fit the whole thing in one screen? Or is that too small now?
No, that's good.
Let me know when you've got it down, because now that I've got it shrunk and I want to put something on the other side.
I'm good.
The other possibility where we had the z-score was equal to the data value minus the mean over the standard deviation. We did the work we just did with the variables. We have that the z-score times the standard deviation is equal to the data value minus the mean. Or we have that the z-score times the standard deviation plus the mean is equal to the data value. And so if you want to remember another formula, you could. That would be the formula we'd need. And then we would go through and do the work. The z-score was 1.3 times the standard deviation was 4 plus the mean was 70, and it would give us that same 75.2 for the data value. So 2 different approaches depending on whether you see the glasses head empty or half. So let's do one more example like this. Let's, for our example, say on SAT, which again has a mean of 500 and a standard deviation of 100. Let's find the score that corresponds to a z-score of, oh, let's say negative 0.47. I'm going to shut up for a minute and ask you folks to work this out. And then we'll go back and do it together if necessary.
Can you lower the screen down just a little bit?
Sure, what did you need? The formula?
Yes, please.
We can use that the z-score is equal to the data value minus the mean over the standard deviation.
Thank you.
You're welcome, sorry. I have to apologize. The surface that I'm writing on, it's only about the size of like a sheet of paper folded in half. And that's why I keep rolling things up, because I don't have a lot of writing room. Did anybody else get 453?
No, I got 970.
Okay, if you got 970, I am guessing that the problem came when you cross multiplied. Give me
Oh,
a-
I didn't do negative.
and also,
Oh, wait, now I got 30.
I think you might have.
Oh, wait. Yeah, I
What
put it in wrong. I put in negative 4.7, not,
0.47 times 100
okay.
would be 47.
All right. Alrighty.
Okay, everybody else okay?
Mhm.
Yes.
That's correct.
All right, and now as I'm thinking of where we're going next, I'm very mad at myself because I forgot to open the virtual textbook and I need to do that. But first, let's go through and let's look at a definition before I start fumbling around with that virtual textbook, okay?
Uh-huh.
So next thing we're going to talk about are percentiles. Has anybody ever heard that word percentile?
Yes.
Yeah. Percentile is the percent of data, or actually the percent of the population at or below a given value. Let's go back to that example of the SAT exam. On the SAT exam, if I, let's say, score at the 50th percentile, what does that mean? Does that mean I did really, really poorly on that test? And it's
It
like,
means you're average.
yeah, it means you're average. It means you did better, did as well or better than 50% of the population. It means your score is right in the middle. A lot of times when you get standardized test results, they give you your percentile, which isn't really a percentage score, but rather, again, a comparison between you and everybody else who took that test. I know that when my children were little and I used to take them to the doctor for their annual physicals, I was always told what percentile they were for height and weight. And so my kids were always at the 25th percentile for height, which meant that they were only taller than 25% of the kids their age. So they were kind of on the short side. They were below average. But they were also always at the 75th percentile for weight, which meant that they were heavier than 75% of the kids their age. They were a little on the heavy side for weight. So go show, who would think that I would have short, chubby kids, right? Oh boy. I know my grandson that was born in June because he was premature. He's at like the 5th percentile for height and the 10th percentile for weight, which means all the way around he's like on the small side, but he's catching up. So when I look at something like the SAT exam, those of you who took the SAT exam, do you remember it was a big whoop-de-doo deal and everybody had to take it at the same time on the same day all over the country, and so
Yeah.
hundreds and thousands of people taking this, probably millions of people taking this test all at the same time. How do you think they figure out that you were at the 50th percentile? You think that there's somebody in an office somewhere that takes all of the graded papers and stacks them up from the lowest score to the highest score and counts how many people were better than you and how many people were below you? Do you think they do that for everybody?
No.
No.
Oh,
What happens is you can use the z-score to find the percentile if the population is normal. And it's close to that idea of the 68, 95, 99.7 rule, because if I look at 68, 95, 99.7 rule, when I go up each standard deviation, it's like a z-score of 1, a z-score of 2, and so on. And so, and the other way, it would be like having a z-score of -1. And so if I ask, let's see, if this is the middle 68%, then below that would be, let's see, we take 100 minus 68 and divide it by 2, which would be 32 divided by 2, which would be the 16th percentile. If I'm 1 standard deviation below or a z-score of -1. And so we could manipulate our 68, 95, 99.7 rule for those whole numbers. But what if the z-score is a fraction? What if the z-score is not a whole number? If the z-score is not a whole number, there's a table for that. And so again, I have to apologize. I should have uploaded these 2 tables to today's notes. If you give me a second, I'd like to look at first a table for the general normal distribution. And this is if somebody were taking a statistics class, you'd be given a z-score table that gives you the percentages for a normal distribution, depending on how many standard deviations you are away. And if you look at this table, this is the negative half, and then I'm going to scroll up. This is the positive half. And please notice that you would use this table for any z-score rounded to the nearest 100. So for example, let's say on this table, if I had a z-score of 1.73, I'd go to the 1.7, then I'd go to the 0.03. And so do you see how it would give me the decimal 0.95H2, which means it would be 95.H2%. And so that normal distribution is so standardized that we can, for any z-score to the nearest 100th, work it out. And that's for scores, and it would be for SAT scores, it would be for heights, it would be for IQs, it would be for prices. It's amazing how predictable things are that fit the normal distribution. But don't worry, this table is well beyond what we're going to be using in our class. instead in our class, oops, I gotta go back to the, in our class, the Z table that you would use is usually built in to the question. However, let's go to statistics. In statistics, let's go to the problem solving with a normal distribution. And let me real quick. I'm sorry, I'm going to have to scroll through the book for a minute. And of course, now it's going to take its time. Oh dear. Sorry, guys.
Mhm.
Perfect. The exact page that I wanted. Over here, do you see that the table that we're using isn't nearly as intricate. So if I wanted to say the percentile for a z-score of 1.7, it would be here 95.54. So somebody who scored at the one with a z-score of 1.7 would be at the 95.54 percentile. And so let's go back real quick and recycle some of the numbers that we did. I think when we were looking at comparing a 5-foot tall man and a 6-foot tall woman, for the 5-foot tall man, we had a z-score of negative 2.5. And so do you see with that z-score of negative 2.5, that guy was at the 0.62 percentile. So he was shorter than, that's even below 1%. As opposed to if we look at that 6-foot tall woman who had that z-score of 2, you see she's at the 97.72 percentile. So she's taller than 97.72% of women. And so I'm going through this kind of quickly because I'm looking at the clock and realizing that we're kind of short on time. So we'll pick up from here next class. But this is
Okay.
where these scores become useful, because if you know the population mean and standard deviation, if you know that population is normal, you can go through and find a z-score and find a percentile for any value. The percentile gives us the percent below, but we can use it to find the percent above. We can use it to find the percent between. So on Friday, we'll be looking at using the z-scores to find percentiles. And we'll also be looking at the last thing we have to discuss is a formula that's used to find what your sample size has to be in order for your using your sample to predict the population to be accurate. So putting all of that aside, let's see, I'm going to change my pen back into a mouse. I'm going to clear what I wrote. I'm going to go back to the notes for a minute. Oops, let me clear what I do. Let me stop sharing my screen. How is everybody with this idea of how to find a z-score and kind of, you know, what it's telling us, where we stand in comparison to the rest of the population?
It's all right, I guess.
All right, well, I know I
Excuse me.
was going to talk couple of you in class. And Maru, I did not get that you came in late. I'm going to do that right now. I did get Zorianne that you came into class, and Kylie, I did get that you came into class. Was there? Oh no, Hussein. I'm sorry, you also came in late. I think I did get that you came into class.
Thank you.
Is there anybody else who came in late that I did not get? If not, have a wonderful Veterans Day.
too.
You too.
You too.
We'll see you on Friday.
All right. Bye-bye.
Thank
Bye.
you.
Bye.
Hi.
Hi.
So about the quizzes and stuff.
Mhm.
So I think I have like 2 more homework assignments that I just have to finish, and then do you want me to email you and be like, okay, they're all done, and then talk about like the points?
I think that's great.
Okay. And then I forgot to write down for yesterday's quiz that we had, the writing it out, because I just did it all on my computer or my calculator because I already knew what to do. So I forgot to write it down. Is there any way you could send me the question so I could just do the work and show you? Because I forgot to do it.
Yes, send me an email reminding me that I promised you to do it because I have a class, another class that starts in like 8 minutes, so I'm not going to have time in between to do that. But
Okay.
send me an email to remind me and I'll do that for you.
Okay, cool. Thank you
Okay.
very much.
All right, you're welcome.
Have a good day.
You too.
Bye.
Bye. Ariel?
For quiz number the quiz number
Dental
2.
presidency. Yes.
Yes. For question number 2, I wanted to know if you know what I put for the answer because you said in order, but I thought I did.
I'll tell you what. You if you have a second, I can pull up your work and show you.
You have a second.
Okay. Omaru, was there anything that you wanted to do, or are you set, sir?
Yeah, I just want because like I know I've been behind because you know I haven't, and I just want to know like what did I miss? Like the assignments that I missed.
All of the assignments are in my labs. They'll say past due. You can still work on them. You'll still get credit, just not full credit, but anything's better than a 0. And all of the notes that you missed are in Blackboard. There's also recordings in Blackboard of every class that you missed. Do you know where to find those?
Yeah.
Okay. So why don't you start because there's no class Wednesday, you'll have no school Wednesday. Hopefully you'll have ample time to like do a little bit of catch up. When you're caught up, send me an email and we'll talk about it. Okay?
Thank you.
All right. So we'll see you on Friday.
Yeah.
Okay. And okay, I didn't want him to see your grades. Can you close your eyes for just a minute, hon? Because I don't want you to see everybody else's grades.
Yeah.
So let's go all the way over here, and you're towards the back of the alphabet. Scarborough, Janisha. No, that's the wrong one. Oh, I put them, change the order. I apologize. Yeah, this was it. Okay, here it is. Now you can open your eyes again. Do you see over here for question 2, you didn't put them in order. You had 11, 16, 9, and you took halfway between 8 and 15.
I don't see on the screen.
You don't see it on the, oh, that's because I am not screen sharing, stupid me. So you don't even have to close your eyes because I wasn't sharing the screen. Do you see over here in question number 2, hon, you didn't put them in order first?
Oh yeah.
Yeah. And over here in question number 4, you had it wrong.
Yeah, I was so mad at myself because I like how to do like mid-range and I was good at it. So I was really mad at myself.
Okay, well, just be careful. I think I gave you almost full credit for that one, but the other one, I think I gave you half credit for.
Okay.
Okay.
And so, how does the points work? So like my grade is a 50 because I got 2 right and 2 wrong. So whatever grade I get for the work, does it combine with my
Okay.
quiz grade?
No, the one in my labs for quizzes doesn't really count for anything. The one that counts is this one here.
Okay.
Okay. Because if we were doing on-campus quizzes, I would always look at your work and not just do right, wrong. And so that's why I want to see your work. And that's why when I look at your work, that's how the grade gets into the Blackboard grade book. The only grades that I am taking from my labs is your homework average. I'm not taking the test grades from my labs, and I'm not taking the quiz grades from my labs. The only thing coming from my labs is your homework grade. The tests and quizzes are from your work in Blackboard.
Okay.
Okay,
And I have a question.
sure.
I didn't get to check yet, but did you give me extra credit for the last quiz we did? Because you said you was gonna get extra credit to people who had did their quiz on time.
Before I gave extra time to anybody else, I went through in Blackboard, not in my labs, in Blackboard, and added 2 points to everybody's score.
Okay.
Okay?
All right. Thank you.
Okay, all right. So have a good Veterans Day. We'll see you on Friday.
All right. You too.
Hey, and thank you for being so concerned.
Oh, you're welcome.
All right, I appreciate students that care. That's great. Thanks a lot.
All right.
Okay, have a good one.
You too.
Okay, bye-bye.